Hello and welcome back to section 11.5 on the law of cosines. This is section 3 and we will be going over when to use the law of cosines and a few practice problems along with that. So on your notes you've got a section that says when you can apply the law of cosines. So the law of cosines can be applied when you have the measure of two sides and the angle included. So side, angle, side, that would look something like this. If we know this side, this angle, and this side, then we can use the law of cosines, which would tell us what this side is over here. The second time that we apply the law of cosines is if we're given the measures of all three sides. So if you're given the measure of all three sides, that's side, 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 then we use the law of cosines. And the third case is if we have angle and then side 1, side 2. And we went over this in section 11.4 on the law of sines. I will be showing an example of this in part 4 or part 5. However, it is better for you to be using the law of sines for the ambiguous case. So you do not need to know an angle and the opposite side like the law of sines. You can have side, angle, side, or you can have side, side, side. And when you're looking for an angle, always find the largest angle first. And this is when you're using the law of cosines. So again, when you're using the law of cosines, always look for the largest angle first. When you're given three sides, you know which angle will be the largest based on which side is the longest. So that's how we're going to be setting it up in these problems. Go ahead and flip over your notes. We are looking at problem number 2 on the back. So looking at problem number 2 on the back, we've got triangle ABC. We're given angle C is 57, side A is 18, and side B is 24. And because we've got a side, the included angle between and the other side, we want to set this up using the law of cosines, where we plug in the angle in place of the angle in the law of cosines. So we're going to be writing this law of cosines as c squared equals a squared plus b squared minus 2ab cosine of angle C, because angle C, we've already got this angle, so we can plug that in, which is 57 degrees. So now we need to plug in the sides and the angle that we have. We don't know C, side C, but we've got sides A, B, and angle C. So when we plug those in, we've got 18 squared plus 24 squared minus 2 times 18 times 24 cosine of 57. And then we just go ahead and simplify this. When we simplify everything on the right side, we get c squared is equal to 429.4319. And to find c, we just need to square root this number. And you can just take the number from your calculator, store it in your calculator, take the square root of that, and c comes out to 20.72. And again, sides, we want to round to the nearest hundredth and use that value for finding the rest of the triangle. Now, because we already have angle C and we just found side C, we've got the opposite. So we've got this side is 20.72. That's across from angle 57, which means we can now use the law of sines to find either of the other two angles, either angle A or angle B. I'm just going to go ahead and do angle B. You can do whichever one you want to use. When we set this up, we've got sine of 57 over 20.72 is equal to sine of angle B over 24. Now we cross multiply and simplify. And angle B comes out to 76.3. Now we know two of the three angles, so we can go ahead and subtract from 180 to find angle A. And angle A is 46.7 degrees. So now we've solved the triangle. We found angle A is 46.7 degrees. We found that angle B is 76.3 degrees and side C is 20.72. So now we're going to look at problem number 3. And with problem number 3, we're given the three sides of the triangle. So that means that we need to solve for the largest angle first. And again, every time that you use the law of cosines, when you're given the three sides, you need to solve for the largest angle first. The longest side is side C, which means we want to set up the law of cosines in terms of C so that we can solve for angle C, which is going to be the largest. Now, the first problem that we did in part 1 of 11.5 was similar in terms of we were using the law of cosines to solve for an angle. And you can do it that way where you plug in the numbers and solve for angle C the way that it's written, or we can rewrite the equation so that we've got it in terms of the angle. So if we move 2ab cosine of angle C over to the left side and subtract c squared from the left side, put it on the right side, we can now get rid of the 2ab in front of cosine of angle C so that we're left with cosine of angle C. And this allows us to plug in the three sides A, B, and C so that we can solve for angle C a little bit more quickly. We've got 7 squared plus 9 squared minus 12 squared over 2 times 7 times 9. When we simplify this, we get cosine of angle C is equal to negative 0.1 repeating. So to get angle C, we need to do the cosine inverse, and the cosine inverse of negative 0.1 repeating is 96.4 degrees. And now that we've found angle C, we can go ahead and solve for angle B. And at this point, you can use the law of cosines or the law of sines because we've got one angle and the side across from it, as well as another side. For this problem, I'm just going to go ahead and finish it off with using the law of cosines again, but again, you can do it either way. Since we already rewrote the law of cosines in terms of solving for an angle, we know that cosine of angle B is going to be equal to, and we just changed this formula so that instead of having a squared plus b squared minus c squared, we've got a squared plus c squared minus b squared, and that's over 2ac. When we simplify the right side, it comes down to 0.6 repeating. And to get angle B, we need to take the cosine inverse of 0.6 repeating, which comes out to 48.2 degrees. And now that we've got two of the three angles, we can go ahead and subtract from 180 to find angle A, 35.4 degrees, and this is angle A. So we have solved this triangle. The last problem, number 4, says a medical rescue helicopter has flown from its home base at point C to pick up an accident victim at point A, and then from there to the hospital at point B. The pilot needs to know how far he is now from home base so he can decide whether to refuel before returning home. So how far is the hospital from the helicopter's base? To find the distance from the hospital, the second point, so point B, to the original home base, point C, means that we're looking for side BC. So side BC is what we're looking for. Go ahead and call that X. And this problem, we've got a side, another side, and the angle included. So this is side, angle, side, which means setting up the law of cosines, we want to put this in terms of angle A. So go ahead and try finishing this problem. We get that the distance from the hospital to the base location is 86.12517, and this is miles, so we want to round that to approximately 86.13 miles. And that is answering the original question of what that distance is. This concludes lesson 11.5 part 3. When you're ready, go ahead and take the assessment and then carry on to part 4.